All right, this is our 2019-2020 Algebra 2, Test 1 through 50 Review Part 1. Is that a whole bunch of numbers and descriptors? Okay. All right, let's start with question number 1. Some of this is, I think, anymore, it's just easier to type. So we're going to say solve the compound inequality and graph the solution set. That's certainly going to be easier to read than my handwriting. So let's start with, say, that our inequality is 2, which is going to be less than 6x minus 4, which is less than, and we'll do less than or equal to 20. 20, period. All right. How do I begin to solve a compound inequality like that? Isolate the x. Okay. I have two options. I could either split this into two inequalities, or I can leave it as one set of inequalities and make sure that I do everything across both sets of inequalities, which is usually what people kind of tend to lean towards. All right. So what's the first thing that you want to do, Eric? Add 4 to really all sides, right? All right, so we're going to add 4 here, we're going to add 4 here, we're going to add 4 there, right? So tell me what that simplifies to. Less than or equal to 24, right? Okay. What's after that? Divide by 6 on all sides. Okay. So what's 6 divided by 6? So we're saying 1 is less than or equal to 4. Okay, so now I'm looking at actually doing the graph. This is correct. Okay, I always start with 0. What numbers need to be on here? Okay, 1, 2, 3, 4. So we got 1, we've got 4. All right. At 1, open or closed? Open. Okay, at 4, open or closed? Closed. Okay, is this a conjunction or a disjunction? Conjunction, meaning that the line is going back and forth between these two things because x is less than 4, meaning it's going this way, but it's greater than 1, meaning it's going that way. So I should get something that looks like that. Does that make sense? Okay, so your work is really this. Okay, can you guys do that? Perfect. Yeah, I can do that. Okay. Let's get to number 2. Okay, this may be a little harder to do. We'll try it. Question 2, determine whether the relationship is an inverse variation. Okay. Then they're going to give you a little chart. Let's see, 1, 2, 3, 4, 5, 6. Okay, it looks something like this. Let's see, we got our x values, we got our y values. Let's say we have 6 and let's say 6, 12. Say 22, and I need a kind of a calculator here. Say 168. We'll say 24 and 154. Let's say 42 and 88 and 56 with 66. Okay. We want to know, is this an inverse variation? Let's see, let's even kind of pull some of these things over here so we have some room to work. Okay. Inverse variation. So this is what the question looks like. But in terms of my work, what does an inverse variation look like? Just the standard form of the equation. Y equals, no, that's slope-intercept, k over x. Okay? In order to determine if this is an inverse variation, what do I have to solve for? K. All right, I need to see that it has a constant. So using this equation here, how do I solve for k? Multiply by x on both sides. Okay, so x times y equals k, or k equals x times y, right? So, all right, so that's all good work. It's kind of in my way. Do we have that written down? Not yet? Okay, let me know. So what are we going to do to test for a constant? Okay, we're going to plug our x and y values across. All right, how will I know if this is an inverse variation? Angeli? They all equal the same number, okay? So they're somewhat random, and they may work like in the test, they may not work like in the test, but we're still looking for the same basic concept, right? So even if this isn't really like the test, our solving process is the exact same as the test, okay? All right, so what's 6 times 612? 3,672, okay? What's 22 times 168? 3,696. All right, can I stop there? Yeah. Now, if that had turned out to be 3,672, I would have had to keep going until I found something. Either I found out that they were all 3,672, or I found one that wasn't. So long as there's one that doesn't match something else, is this an inverse variation? No. Okay, so we're looking at this and saying, no, not an inverse variation. And if I'm going to write a reason for Mr. Wilcox, who's grading my paper, I'm going to say, because there is no, what? What do I not have? I don't have a constant. Or the constant isn't constant. Okay, does this make sense? Okay, so we understand what our work should look like. I would for sure probably write up the inverse variation equation and how to solve for k, and then start showing that math. Okay. All right, let's get back over here. Number 3. Okay, we're going to say given f of x equals 12x squared plus 14x minus 4. Okay, and we're going to say g of x equals negative 18x plus 12. We want you to find f plus g of x. Okay, that's the question. Okay, f plus g of x. All right, so the rest of this is, we'll do in blue, is the work. What do I do? Any takers?
12x squared plus 14x minus negative 42. Negative 18x plus 1.
I plug it into it. Add it. Yes, because we're just looking right here. I think you're thinking of f of g of x, where we would take a function and input it into the x value of something else, right? We're not doing that here. So John's absolutely right. We're taking 12x squared plus 14x minus 4 and adding to it negative 18x plus 12. Combine like terms. Okay, what are my like terms? Negative 4 and 12. Okay, what's negative 4 and 12, John? 8. Okay. Any other like terms? 14x and negative 18x. What does that come out to? Negative 4x. So we have negative 4x plus 8. Anything else? just bring down the 12x squared. Okay? And I'm trying to determine, let me see here real quick if there's any kind of simplification that has to be done. No simplification. That answer right there would work. Okay? So we understand that one should be really easy. Just add the things up, right? Combine like terms, simplify it down, right? I don't have to divide this by 4 or anything like that. I'm not factoring anything out. Okay? All right, let's look at question number 4. Okay, it says subtract. Let's say we've got 10x cubed plus 14x squared minus 14x plus 8 minus 6x squared plus 14. Okay, this one really throws a lot of people. It's really not a terribly hard question. But that minus that exists between those two things means I have to do what? Distribute the negative. So let's go ahead and rewrite this. We've got 10x cubed plus 14x squared minus 14x plus 8. Now what? Let's go ahead and write this as the negative has been distributed. Minus 6x squared minus 14. That negative has to distribute to both of those items. Now what? Just like in the last question, we combine like terms, right? What are my like terms? Okay, negative 6x squared and 14x squared. What does that come out to? 8x squared. Any other like terms we have to worry about? 8 and negative 14. What is 8 and negative 14? Negative 6. Okay, negative 6. Okay. Now for the rest of my terms. Bring down 10x cubed and negative 14x. Okay? And this is the order things need to be in. It needs to go cubed, squared, x, constant. Okay? We get that? Again, we don't have to factor anything out, right? We just distribute the negative, combine like terms. That's my answer. We're good there? Awesome. All right, let's look at number 5. Number 5. We want to know what are the solutions of the absolute value of 4x minus 16. Let's see, minus 6 equals negative 2. Now, what you should notice on this question as you get it is that this is not a multiple choice question. This is a short answer question. Okay, so you're going to have to write in the values. Okay? What are the solutions? Okay, so we're looking at, and I'll just rewrite it here so you maybe see it a little bit better. Absolute value of 4x minus 16 minus 6 equals negative 2. Okay? Absolute value questions have to be solved how many times? Twice. Okay, with an important difference in the second one. All right, what's the first thing you have to do? Add 6. We have to isolate the absolute value. So add 6 to both sides. Okay? So I have 4x minus 16. Absolute value of 4x minus 16 equals 4. And because that equals a positive number, can I keep going? Right? If it had still equaled a negative number, would I stop right there? Right? And I would say no solution because an absolute value cannot equal a negative number. All right? But it does equal a positive, so what do we do next? No. No, I don't add 16. I do 4x minus 16 equals 4 without the absolute value. Okay, so you're adding 16. adding 16. So you have 4x equals 20. Divide by 4. X equals 5. Done? No. Okay, 4x minus 16 equals negative 4. So the absolute value has to also equal the negative number. So that on the inside I get a negative 4 value, but because it's an absolute value, negative 4 equals positive 4, right? All right, so now what do I do? Add 16 again. All right, so I got 4x equals what? 12. Divide by 4. X equals 3. So I'm going to say, as my answer, x equals 5 and x equals 3. Or 5 and 3, or any combination. X equals 5, comma, x equals 3. Just make sure that you have both. All right? If you only have one answer, it's wrong. So if you only have 5, if you only solve for the positive side of it, it's going to be wrong. Okay, do we understand our work there? Okay. Okay, let's see. 6. This one we do want to factor. So it's going to say factor. We're going to say 8x squared minus, let's say, minus 112x plus 392. I'm going to give you harder numbers than what are on the test. Okay, that's all it says. Okay, so let me rewrite it so that we're seeing that x squared, 8x squared minus 112x plus 392. Takers? What do you want to try to do first? Mm-hmm. Okay, notice how the first term is not just x squared, right? So what could you try to check and see is possible? See if 8 goes into everything, right? Does 8 go into 112 evenly? Okay, now I'm not necessarily going to write anything up yet because if it doesn't go into 392 evenly, it doesn't matter. Does it does. Okay, so we're going to divide everything by 8. So we're going to take out an 8. Okay, so we know that would give me x squared, right? What is negative 112 divided by 8? All right, so I'd write negative 14. And what's 392 divided by 8? What is it? 49. Okay, now what I want to do is I should be able to simplify x squared minus 14 plus 49, right? Okay, and break that down into two sets of parentheses. So x and x gets me x squared. Now notice that it's minus plus. All right, which means what are my two signs on the inside? Minus and minus. Because whenever I combine minuses, I still have minus, but whenever I multiply them, I get a plus. All right, what two numbers, when I multiply them, equal 49, but whenever I combine their negative values, I get 14? 7 and 7. So I have 8 times x minus 7 times x minus 7. Now I have one more thing to do, is can I simplify x minus 7 times x minus 7? Do I need to write both of those x minus 7s? No, what can I do? X minus 7 squared, and this should be my answer. That's this factored. Okay? We're good there? Okay. All right. 7. Oh, this is a little harder to show. I'm going to write this in, and I'm going to probably handwrite the rest of it. Determine if the graph is continuous, discontinuous, and or discrete. Determine if it is a function or a relation. Determine the domain and range. Okay? So let's see, I'm going to go ahead and try to do part of this anyway. Let's see, you guys are out of here at what, 10:36? So we probably won't get through. This will probably be the last question we can do. Okay. Okay, it's not a great coordinate plane, but it's there. Okay. Let's say we see something like. No. Okay. I think that ought to be enough information. Is this graph continuous or discontinuous?
Continuous.
What do you say?
Continuous.
Okay. Do we know what that little open circle means?
Oh, no, it's discontinuous.
It's discontinuous because this represents a break, which means at that coordinate, there's nothing there. So we're going to say, and I'm not going to write it all out but we're going to go discontinuous. Is this discrete? Is it a discrete function? How do I identify a discrete function? It's whenever it's just dots. Is this just dots? No, it's not just dots, so it's not discrete. Okay? Is this a function? Does it pass what test? Does it pass the vertical line test? So it's a function. Now you're going to need to determine domain and range. Okay? So I will pick up this portion of it with the other class. Okay? So we at least made it to about 6.5 questions. We'll stop there.